Good morning, everyone. My name is Sopet Punlin, and I'm the freshman of the Civil Engineering Department. And welcome to my video today. Today, I'm gonna explain about the trigonometric substitution from the chapter 8, which talks about the techniques of the integration. So let me show you about my content today. So the objective or the purpose of today's videos is I'm going to explain you thoroughly about what is the trigonometric substitution by telling you the definition first and what is the references triangle. So do you wonder why we have to show the references triangle in order to solve this integral problem? So let's see together. And the third one is the procedure of the integration. So how are we gonna apply the trigonometric substitution into the integral? So let's not wait for time. Let's not waste our time. Let's move. So the trigonometric substitution is a type of techniques to evaluate the integral that contain the radical expressions. So as have shown under here. So how can we evaluate this integral? Do you have any clues? I'm not sure either. So as the definition mentioned that we have to evaluate this integral by substitute the variable of the integration with the trigonometric function. How is that possible? But we have clue from the content, which I had mentioned about the references triangle. So let's see what it really is. So the reference, these are the common and the most used trigonometric function that we have to substitute into the integral. So in the first one, we have x equal to a tangent of theta, which is the function, and we have to draw the reference triangle to show which x is the opposite side and a is the adjacent side. So if you see the function of the square root of x squared plus a squared, we have to use the function of x equal to a tangent of theta, and we just substitute the value of x in, and we have a squared in common, so it can be out of the root. So a of tangent theta squared plus 1 squared equal to the second theta squared. So it can be out of the square root, which we can finalize the answer, which square root of x squared plus a squared equal to a second theta. And the second trigonometric function, which is x equal to a sine of theta. And as we can see in the reference triangle, which x is the opposite side and a is the hypotenuse. So if we see the problem which of the integral, which with the square root of a squared minus x squared, we have to substitute the x equal to a sine of theta in. So we have a square root of 1 minus sine theta squared. And we know that sine theta squared plus cosine theta squared equal to 1. So we have the final answer, which square root of a squared minus x squared equal to a cosine of theta. And the last formula of the trigonometric is x equal to a secant of theta, which x is the hypotenuse and a is the adjacent side. So if you see the problem of the integral, which is the square root of x squared minus a squared, we have to use the function of the x equal to a secant of theta in. So we just substitute it in, and we have the formula of secant theta squared minus 1 squared equal to tangent theta squared. So we have the final answer, which square root of x squared minus a squared equal to the a tangent of theta. And as I had explained about the reference triangle, so how we gonna apply the references triangle, which is the element of the trigonometric substitution of the to evaluate the integral. So let's see the method of solving these problems. So we have the procedure or the process of this evaluation, which we have to write down the substitution for the x, which I had shown you about the references triangle, and we have to calculate the differential of dx because there is a dx in the integral problem, so we have to calculate the differential of dx and specify the selected values of the theta for the substitution. So we have to state the interval of the theta in the process of solving the integral problem. And the second step, we have to substitute the trigonometric expression that we have written down from the first step, and then we calculate the differential into the integrate, and then we simplify the result of algebraically. And the third step is we have to integrate the trigonometric integral, keeping in mind that the restriction on the angle theta for irreversibility. So we cannot keep the theta in the function after we evaluate it out of the integral. So we have to reverse it back into the variable form. And the last step, we have to draw an appropriate reference triangle to reverse the substitution into the integration result. And then we have to convert it back into the original variable x, as I mentioned. We have to convert it back to its original form. So here are some examples that I had written out by myself. So we have the problem of the integral of square root of y squared minus 25 over y to the power of 3 of dy. So in the first step, we have to choose which of the trigonometric function that we have to use in to evaluate this problem. So we have y equal to 5 second of theta, and the differential of y equal to 5 second theta tangent of theta and d theta. And we have the interval if x over a bigger or equal to 1. Then the interval of it is bigger than 0 and smaller than pi over 2. But if the x over a smaller or equal to minus 1, the value of theta is bigger than pi over 2, but smaller than pi. So the second step, we have to substitute it in. And you must remember that we have to remember many common of the trigonometric formula or function, so we could use the substitute and get it off of the square root. And as of this example, we have integral of the 5 to the square root of secant theta square minus 1, 5 tangent theta d theta over 125 secant theta to the power of 2, and the tangent theta to the power of 2 equal to secant theta square minus 1. And we just evaluate, and we have the final answer of the second step, which equal to 1 over 5 integral of sine theta square d theta. And the third step, we have to evaluate this integral, which in the trigonometric form, and we cannot let sine theta to the power of 2 d theta out of the integral, so we have to use the formula which sine theta square equal to 1 minus cosine 2 theta over 2. And after the integral, we have the final answer, which of the third step, which equal to 1 over 10 of theta minus sine 2 theta over 2 plus c. And in the fourth step, we have to reverse it back into the original form of the variable x. So we have 1 over 10 of the theta minus sine 2 theta over 2 plus c. And from the reference triangle, which y equal to 5 secant theta, so we let theta equal to secant to the power of minus 1 y over 5. So we just substitute it back in. We have the final answer of this problem, which equal to 1 over 10 secant to the power of minus 1 y over 5 minus square root of y to the power of 2 minus 25 over y, and times the 5 over y plus c. So this is the solution for the first example. So let's move to the second one. Which the second one, I'm going to use the different function of the trigonometry, which the integral of 1 over x squared, square root of x squared plus 1 dx. So in this example, we have to use the formula of x equal to tangent of theta, and we differentiate this x equal to secant of theta to the power of 2d theta. So theta has an interval of bigger than minus pi over 2, but smaller than pi over 2. So we just substitute the trigonometric substitution the trigonometric function in. So we have integral of the secant to secant theta square d theta over the tangent of theta square, square root of tangent theta square plus 1. So tangent of theta square plus 1 equal to secant of theta square. So it can be out of the root. So we just do the calculation, and we have integral of the cosine theta d theta over sine theta square, and we just use the trigonometric formula, which cotangent of theta equal to cosine of theta over sine theta, and cosecant of theta equal to 1 over sine theta. So we move to the third step, which we evaluate this trigonometric function. So we know that the differential of the cosecant theta equal to minus cosecant theta and cotangent of theta d theta. So cosecant of theta equal to 1 over sine theta. So in the third step, we have the answer of minus 1 over sine theta plus c. And in the fourth step, we have to reverse it back into the original form of the variable x, which sine theta equal to the opposite side over the adjacent side, which the opposite side is x and the adjacent side is square root of x squared plus 1. So here's the answer of our integral problems. So let's move to the third example. So in the third example, I had mentioned about the different function of the trigonometric, which we let x equal to sine theta. So let's see what is our problem for this integral, which integral of the 1 minus x to the power of 2 to the power of 3 over 2 over x to the power of 6 dx. So let's don't be panic when you see this kind of weird expression. So we have to solve. So we just use the substitution and then solve it trigonometrically or algebraically. Just do it. Don't be panic. So we just let x equal to sine theta, the x equal to cosine of theta d theta. So the theta have the interval of the bigger than minus pi over 2, but smaller than pi over 2. And we just substitute it in. We have the integral of the 1 minus sine theta square to the power of 3 over 2 and the sine theta to the power of 6. And the differential of the x equal to cosine of theta d theta. So 1 minus sine theta square equal to cosine theta square. So it can be out of the root now. We see that we have the integral of the cosine theta to the power of 4 over sine theta to the power of 6 d theta. And cosine of theta over sine theta equal to the cosecant theta. So we use the cosecant of theta to the power of 4 and 1 over sine theta equal to cosecant of theta. So in the third step, we have to evaluate this trigonometric function. So we just differentiate the cotangent of theta equal to cosecant of theta square. So we just evaluate this. We have the final answer, the third step, which equal to 1 over 5 cotangent of theta to the power of 5 plus c. So we have to convert it back into the original form of variable x. So the cosecant of theta equal to the adjacent side over the opposite side. So the adjacent side equal to square root of 1 minus x squared and the opposite side, which is the x. So we have the final answer, which is minus 1 over 5 square root of 1 minus x squared over x to the power of 5 plus c. So this is the end of my example. And thank you everyone for your time watching this video, and thank for the support. And thank Mr. Kasim for your effort to teach us for this 2 semester and I understand it well. And thank to Mr. Ihian for assisting me on the study and also for the idea of this video. Thank you. Please click like and subscribe and see you in the future. Thank you.